This is one more interesting question, and this question came in all the exams, okay? In IIT exam, in GATE exam, as well as in CSI NET exam. Level of asking question is maybe different, but this type of questions already came in all the three, okay? So, actually, this question have so much information, but I will tell you how directly we will solve this question, okay? Just remembering few things, two or three things, you can answer this type of question easily, okay? So, apart from this, if you have any other question that you want to understand related to this or any other subject, you can ask me, okay? And ask from the system from wherever you are learning, okay? Only that because we need geology craze in us so that we can crack all the exams, okay? So, and share this video with your friends so that they can also get benefit, okay? And discuss among each other, okay? And still, if you have any query, you can ask me, okay? Now we'll directly go to our question, okay? So this question is basically with the binary phase diagram, okay? Phase diagram, okay? So how to read this phase diagram? It is a, we have two component M and N, so it is a binary, okay? It is binary phase diagram, okay? And which binary phase diagram, okay? It is continuous. Continuous. In Bowman reaction series, we have seen a continuous discontinuous reaction series. It is a continuous reaction series. Okay, the mineral that are forming. Example of this is albite, anorthite. Okay, in olivine also we have seen. In olivine group we have seen. Between phosphite and phyllite. Okay, continuous reaction series means the mineral that form will react with the remaining melt. Okay, and forming a new phases. Okay, until it is not reached to its end of the stage. Okay, means now for solving this question, you just remember two things. Okay, suppose this is our given melt composition. Okay, so we have to cool this. Okay, so while cooling this, our temperature will drop. So we will reach to this curve. We call this curve as a upper curve. We call it as a liquidus, and lower curve we call it as a solidus. Okay, so after reaching at this point, okay, we have to draw some horizontal lines. Okay, first horizontal line will come like this. Next, suppose I have reached here and I will draw this horizontal line. And in next, I have suppose reach here and I will draw again horizontal line. Okay, so for this line, they are marking this. Okay, for this line, we will mark. Okay, and solve this. Okay, from here to here, one more line I have to. Why I am drawing three lines? So that our concept will be clear and we will easily answer by seeing this only. Okay, we need not to waste our too much time on this. Okay, in exam. Okay, so now one thing remember that if that liquid is this the composition that we are given, draw a vertical line like this. Okay, in equilibrium case. Okay, equilibrium melting case. Okay, like this. Okay, and if our liquid is on left side, okay, if our liquid is on left side, okay, upper side, okay. So we will call this horizontal line from here to here, from here to here. We call it as a solid. Remember this, okay. And this side, the lower side, in which we are getting solid and this liquid plus solid contact, we call this line as a liquidous composition percentage, okay. Liquid percentage we calculate from here. Actually we are using lever rule, okay, but without using lever rule I will calculate this, okay. We just seeing this graph itself, okay, but how we will use this, you should have some idea, na? At what time we will use lever rule? When our these numbers are in points, na? Like 48, 43, in that way, to calculate the accurate number, okay. Okay, how we will do that I will tell you, okay. So next thing is, okay, you understand that this downside means right side is our liquidus curve and left side is right side is our solidus curve and left side is our liquidus curve. Suppose this diagram is reverse of this, okay, in this way it is, okay. So in that case, this side is our, this is the dotted line, here we have drawn some horizontal line, tie line, we call this side now our left side is our solidus curve and this side is our liquidus curve. Just remember this, okay, one point, okay. So now if I will change the color, okay. Now first we will calculate for this one, okay, the question that are given to us, okay. Then we will solve the rest of the things. I will draw this. This is the tie line that are given to us to calculate what is the percentage of liquid composition in composition L. Okay. So how we will calculate? We have to draw some horizontal these vertical lines. Okay. Already constructed. We know the number 60, and here side it is 20. We need not to remember this also. We will directly tell. Okay. How many divisions are there? Here to here, one division, two division. Two division is on our left side and two division is one on right side. So it is in between. So we will get how much? 50-50. We will get 50-50. 50 in liquid without using any formula, just the graph. Okay. This is solid. How we will read? This is the line. This is that line dividing, and here we are getting two parts, and this side also we are getting two parts. So both side 50-50. So in our question they are asking about liquid, so our liquid is 50. If we are telling about solid, solid is also 50. Now, if our, I will change the color, okay. Now suppose if line is this one, okay. So now in this case, right side we are not getting anything. So there is no solid. But in this case, don't go like this, okay, down and calculate this 10, 20, 30. No. Okay. So this side only what we are getting only liquid now. So it is 100% liquid. It is 100% liquid. In that way we are reading. We are not reading these values, okay. We are just reading this, okay. 100% liquid and 0% solid. In a similar way, we'll use the color this line. Color is not getting good. Brown, yes. Okay, up to this only. Okay. So now how many divisions? 1, 2, 3, 4. Same. We're getting same. So same 50-50. No, it is not like that. Okay. If you contradict it, if you stop the video and listen again, and then it's okay. So in this case, over this equilibrium line, we are at a which side? We are at a right side. Only solid will form. Only solid will form. This liquid is zero. We need not read this. Okay. How much is the gap? Okay. Okay. I will tell you. Okay. This value. How these values are coming. Okay. So now using this value, what directly I am telling. Okay. So there is one more line. We will use that line also. Okay. Suppose this is our one more line. Okay. So this side only how much? We are only having 1. And this side we have how many parts? 3. 1, 2, 3, and more than 3 little bit. Or 3 we can say. Okay. So how much? This side we are having 25% and this side we are having 75%. Only then we will make 100%. Okay. And in this case, this green one, in this case, all things we are getting in this side. This side we are getting 0. That's why we are getting 0. Okay. And now everything is on here side. 100%. Okay. Percentage in percentage. Okay. So 100% in a similar way for that blue one also. Blue one I have already mentioned. Okay. So now for this line, right side is our solid. How many? Oh, how much is the solid? 75%. 75% is the solid and 25% is the liquid. Okay. This 50-50 is for this blue line. Okay. For this green line, we are getting liquid 100% and solid 0%. And while because it is at the upper boundary. Okay. Now, if we want to read this value, what this value represent? What this value represent? Okay, by using this. Okay, we'll use only for this. What will make difference? We will read these values. Okay, purple. Okay, so that our concept will be clear. Okay. So now how we will calculate this for this purple and how we will calculate this? This okay. How much? This is a center line. Here we are getting 30, and this side we will get how much? 10, 20, 30. Okay, this side we are getting 30 and this side we are getting only 10. Total is 40. To calculate liquid, okay, the liquid is how much? This side is our solid, this side is our liquid. So liquid is 10 divided by total. Total is 40 into 100. So in this way we will get our 2.5 is 25%. We want to calculate for solid. Solid is how much? 30, 10, 20, 30. 30 divided by 40 into 100. So we will get over 75. In this video, I'm not telling any concept. Okay, I'm just read the graph and how to approach the answer. Okay. So if you need a full concept, okay, and binary ternary diagrams, okay, you can mention in the comment box. Okay. And if you have any other difficulty in any of these questions, you can directly mention in the comment box. Okay, I will solve that part also. Okay. So hope you learned something from this video. Share this video with your friends so that they can also get benefits and ask questions from the system. Don't wait for the opportunities, guys. Okay. Thank you. Hope you learned something.